For this podcast, please have note page number 19 in front of you. Next in our series of functional groups, we are looking at the esters. Now, an ester group is going to have a double bonded oxygen and then also a single bonded oxygen. All right, within a organic chain, you can see that the general formula, you have a portion of your organic compound here as well. And then as you can see the double bonds of the carbon. Also attached to the carbon is a single bond. Here's an example as well. This we have methyl propanoate. Here is what gives us the idea that we're dealing with an ester. All right, there's your double bond of oxygen and your single bond of oxygen. All right, now on page number 19, let's get into a little bit more detail of what these esters are all about. Like I said, within an ester, you're going to find its double bond of oxygen along with a single bond of oxygen as well, and at either end, you're going to find portions of your organic compound. Now, the key is making sure that this right here, this carboxyl group, if you will, is connected to the parent chain. All right, and then to the branch as well. So this oxygen here, right there, is going to be connected to a branch, and then this portion up here is going to be connected to the rest of the chain itself. So it's important to understand that this carboxyl group right here is attached to a parent chain. The hydrocarbon chain contains this piece here. Right. It is within the parent chain, like we noted up above. In order to name these esters, what we're going to do is we're going to place the E at the end of the name and put in an O8. O8. The hydrocarbon chain, single bond to oxygen, is the branch itself. So where the oxygen is located within this monster here, that's where you're going to find the branch come off, right here at this position. Name it as you would any other branch that we have up to this point. And the nice thing with esters is that they are known for their very strong fragrant aromas like wintergreen, mint, and even in some fruits. All right, the examples that are provided for us. Here we go. First example, we have the name of the ester that's involved. You can see that our branch is identified first. And then the longest possible chain, our parent chain, is going to have the butane piece to it. So we know our longest possible chain is going to have 4 carbons. The ethyl group illustrates that we have 2 carbons associated. And then the O8 piece here tells us that we're dealing with an ester. So let's get our longest possible carbon chain drawn out first. All right, we know we're dealing with a butane group. Here is going to be the location of double bond of the oxygen and the single bond of the oxygen. Like we said up above, the single bond of the oxygen is going to have the designation of where the branch is going to be located. Ethyl group knowing that we have 2 carbons attached. Finished off with some hydrogen bonds. Hydrogen here. Of course, we're going to have hydrogen bonds located here as well, making sure that we have 4 bond sites for each of the carbons here as well. Okay, so within this structure, here's the indication of our ester. All right, like the directions illustrate, we have a branch coming off the single bond of the oxygen, which is going to make this ethyl. Here's our branch, butanoate. Right, and there's our 4 carbon chain right there. Now, another example. Let's take a look and see what we have here. Our longest possible carbon chain is going to be 1, 2, 3. So we know that we're dealing with prop. We know that it's going to be an ester. Right, there's our ester, so we're going to have O8 at the end. And as you can see, we have a branch. Here's our branch coming off of the single bond of oxygen. And this is going to be a methyl group. because of the one carbon that's present. So methyl propanoate. Our next one, we have propyl methanoate. Right, so we're dealing with 3 carbon chain. So because of the propyl piece. Here's our main bond, just a single carbon. So here's the location of our piece that makes this an ester. Of course, coming off here, we're going to have one more hydrogen. Off of the oxygen, of course, is going to be our branch. So carbon here, carbon there. And you know that we have a 3-carbon branch because of this here, the propyl group, methanoate. So here's what indicates that we're dealing with an ester. That's the methyl piece. And over here is the location of our branch coming off of our single bonded oxygen. Esters.